So yeah, hello everyone. So today we will talk about muscle physiology. We'll study muscle physiology. Everyone, muscle physiology. So muscle physiology. Okay. So first of all, before starting muscle physiology, we'll get to the part of what are the units of muscle physiology. So suppose there is. Can I draw? Okay, wait a second. Let me put my mouse. Let me put a mouse. So I pause it. I won't pause it. I will count you on because I love you guys and I know you will wait for me. I know you will appreciate the word. So yeah. So first of all, suppose this is our muscle. Okay, yeah, this is your muscle, and you are showing off to your to flex. Okay, and so if you zoom it, you will find a lot of muscle fiber. Okay, which are connected to your bones. So this is your bones. This is your muscle fiber connected to your bones. So and the connection, the thing that connect your muscle to your bones, okay, is called. Let me erase it. Is called a tendon. Okay, that's a great thing to know about. So if we then further divide the muscle fiber, then if we divide the epithelium, then we'll get a fascicle. Then we further divide muscle fascicle. We'll forget muscle fiber. So these are the method we can use to get I mean to find the three type of muscle method. Okay, these are the thing. So if we want to get to know from my extra chat GPT, okay, he told me that how can we identify which type of muscle fiber it is by this histochemical method, then this thing. So these are the things that we have discussed. First of all, what histochemical is that? What I so is that histochemical method is that, see, our muscle are kind of a three type of muscle fiber we have. The type A, the type 2A, the type 2B. Okay, the type 2A is our fast slow twitch oxidative. Okay, it works with slow, but it is steady and it is carry on. You can kind of like a regular muscle type. This is okay. These are mitochondria take oxygen and produce ATP. These are very simple thing. And there is involves on myoglobin. Okay, but they do slow thing because you cannot get a weak oxygen supply is limited. Okay, you cannot get a lot of oxygen in a single amount of time. So okay, so it says that there is slow, there is fast, there is super fast. Okay, so scientists have special sticker called antibodies. Okay, they stick only to slow worker, and another nerve sticks to fast worker. Okay, there are two types of sticker. Okay, you can actually remember as color patch. Okay, slow as red, medium as blue, fast as green. So what happen is that when you put all the muscle fiber into a special gel, okay, that's a gel. You put it mother. So you there is a muscle fiber. You put it, and you will get. The problem is that there is no option of pausing anymore. Then what? To completely edit the video. मुझे बात करना. So if you put it on a special gel, the type 1 will go slow, the type 2 will run faster because they are faster, and the type 3 will run fast. Muscle will run anyway. ମୁଁ ରେକର୍ଡ କରୁଛି ଆମେ ରେକର୍ଡିଂ ଆମେ ପ୍ରଫେସର ବ୍ରୋ you don't understand he don't understand. Let me change the color. Now looks fine. Okay. So type 2, so from immunochemistry, as we have give badge to each muscle fiber, so if we would get it know that this badge faster, runs faster. So this is a slow twitch. So this is kind of a technique we use, histochemical staining from myosin ATP base. Myosin ATP base. Remember this. Okay, and this can be done by ammonium sulfide method. So where does ammonium sulfide use actually? Do we know it? Do we know it? No, we don't know it. Ammonium sulfide staining. Okay. So that's how we can distinguish type Y by versus type 2. Okay. I don't know what those slides mean. So okay, let's get to know each by actually understanding the kind of twitch fiber. So this video actually
Actions and
explains.
greater
This
number
video
of
actually explains the three type of muscle fiber.
metabolism, but can switch to anaerobic metabolism if the need for energy is urgent. These fibers are resistant to fatigue and can sustain contractions for a prolonged period. However, their endurance isn't as remarkable as that of type 1 fibers. Type 2A fibers are also capable of generating faster contractions and higher tension than type 1 fibers, but less than that of type 2X fibers, which we'll see next.
See, when it comes to, there is terminology that you have to understand. When it comes to stamina, what is the word again?
Type 2A fibers are also capable of generating faster contractions and higher tension than type 1 fibers, but less so isn't as remarkable as that of type 1 fibers. Type 2A fibers, hence their nickname, intermediate fibers. Unlike the slow twitch fibers we discussed earlier, type 2A fibers are larger and more numerous than type 1. They're quite the all-rounder. They primarily rely on aerobic metabolism but can switch to anaerobic metabolism if the need for energy is urgent. These fibers are resistant to fatigue and can sustain contractions for a prolonged period. However, their endurance isn't as remarkable as that of type 1 fibers.
My girlfriend is
Type
texting.
2A fibers are also capable of generating faster contractions and higher tension than type 1 fibers, but less than that of type 2X fibers, which we'll see next. These fiber types are recruited for contraction after type 1, but before type 2X muscle fibers. Type 2A fibers possess a greater number of mitochondria compared to type 1 fibers, as well as moderate amounts of glycosomes, which store glycogen or glycolytic enzymes required for anaerobic metabolism.
So this is how I get disturbed while studying. ନାଇଁ ନାଇଁ ମୁଁ କଥା କହୁଛି ମୁଁ ମୋର ଲେକ୍ଚର ପିଲାମାନଙ୍କୁ ଷ୍ଟୁଡେଣ୍ଟ ମାନଙ୍କୁ କହୁଛି ଯେ ଡୋଣ୍ଟ ଗେଟ୍ ଇନଭଲ୍ଭ don't get involved in ladki patana while studying. So that's how, because having a ladki is can be very disturbing. So this is a very important fact to remember everyone. So because don't involve in ladki patana and all. Okay. Last text. Stop playing. So yes, okay. So we are studying that what you let me revise what you have studied. Type A fiber have a high stamina and a low high endurance. Endurance means the amount of time you can actually work without a fatigue, but they are not that strong. They are not that they're resilient, but they are not powerful as type. Type three fiber.
However, when it comes to myoglobin content and capillary density relative to their size, they lag behind type 1 fibers. This
See, myoglobin capillary activity that deal with your oxygen. That how I can convert the oxygen into energy. Because type 3 fiber, type 2 fiber doesn't have anything to do with oxygen. That's why they have low density.
slight difference in
Simple.
composition results in a lighter pink coloration. These characteristics make type 2A fibers intermediate in terms of their properties. They're like middle
Intermediate. Okay.
ground between endurance and speed. Type 2A fibers
So the picture actually depicts the fiber because the natural muscle are mostly type A fiber. The muscle we actually gained, by heavy lifting, like this muscle by lifting. These are all mostly type 2 fiber because we matlab, we only tear type 2 muscle while we work out. So when we tear this muscle small micro tears, they develop back and this type 2 muscle only grow back.
are particularly useful for prolonged movements that require more tension than what type 1 fibers can generate, such as running or swimming. They provide the necessary endurance and moderate force production for these activities, making them an invaluable asset for our average runner in lane 2. Lastly, we have the fibers that we saw in action in lane 3 of the Ken Hub race. This sprinter was mostly reliant on the type 2X fibers. These muscle fibers are all about speed and power, and they achieve this by primarily relying on anaerobic metabolism, specifically glycolysis, for energy production. This metabolic profile equips them for fast and high-intensity contractions. However, there's a trade-off for all this speed. They tend to fatigue more quickly compared to other muscle fiber types. This happens because the lactate produced as a
Low endurance.
byproduct of anaerobic metabolism causes a local acidosis, increasing muscle fatigability. Type 2X fibers also have a substantial glycogen depot, like a nitrous boost for a race car. This reserve glycogen supply allows for the rapid release of glucose, providing the energy needed for quick and forceful contractions. Morphologically, these fibers are larger in diameter and appear whiter in color.
This is the one
This
thing
unique
to remember.
appearance
Larger in diameter. Type 2,
is
too
attributed to
big
their
fiber.
limited
Big
reliance
type.
on oxidative phosphorylation, resulting in a lower density of mitochondria, capillary structures, and myoglobin content. So type 2X fibers are the go-to choice for explosive, short bursts of anaerobic effort. Activities like weightlifting, sprinting, and jumping predominantly recruit these muscle fibers. They are the muscle workhorses responsible for generating rapid and powerful muscular contractions, just like our sprinter in lane 3, leaving nothing but a streak of speed in their wake. If you found this quick anatomy or physiology video helpful, you'll enjoy our video tutorials even more.
So that was the thing about this slide. Okay, they have larger diameter. We remember they have large glycogen storage because why do they have large glycogen storage? Because they need energy, right? Because they need a glucose. Large calcium pumping ability. Why do they need large calcium pumping ability? I don't know. Let's ask to the ability that why. So this fiber have highly developed sarcomeric reticulum. The sarcomeric reticulum resolve calcium very quickly. Okay. Yeah, of course, because calcium to quickly. Khacha, khacha, khacha. Fast calcium handling require rapid contraction, relaxation, and working. So that's why they have lots of K. Got it. A few mitochondria and blood capillaries because type 2 fiber only rely merely on anaerobic glycolysis. They rely mainly on anaerobic glycolysis only. Energy from glucose without oxygen. Type 2 fiber only rely on mainly on anaerobic glycolysis. Mitochondria is for aerobic, capillaries. Acha. Salt in transport, not endurance. Lactic acid buildup. See, the lactic acid buildup is a very big problem. Yeah. And to understand this graph is a very important. Myoglobin versus hemoglobin. Let's ask to ChatGPT to understand this graph and which I've already asked. So hemoglobin is oxygen delivery truck kind of you can say. So it's oxygen protein teaching. This is found in blood, especially in red blood cell. So it picks up the oxygen from lungs, then it delivers to your muscle. That's what it does. So the problem is, in it has four seat only has four hemi groups, which can only carry four oxygen molecules. But myoglobin is a storage drug. It is inside the muscle cell. It has only one hemi group. So you can see that only one hemi group. So there is very less oxygen around. So you can you have very limited seat. Okay. So its job to store oxygen release until unless when needed. So you can see at the starting point P50 means how much oxygen is around. Okay, there is a cell how much oxygen is around it, and oxygen saturation is how much oxygen they are actually transporting. So first because hemoglobin has more seat, okay, they have more capacity. They could able to take more than myoglobin. Okay, so they could able to take more than myoglobin at first, and there is at some point they actually get intersect. Okay, so let us ask what is that region. The oxygen pressure is 150% full hemoglobin. The PP is higher, needs more oxygen to fill up hemoglobin. The P50 is lower. Oxygen pressure at 50%. That will do the oxygen. Okay. Why does they saturate both at same point? So are the food chain when they are completely occupied, of course they'll saturate it. Both myoglobin and hemoglobin cannot hold more than their maximum number of O2. So when the oxygen is abundant, both are at full capacity. That's why no matter how different the curve look like, low oxygen level at PO2 at high PO2 around both hit 100%. Okay, that is all. That is all about today. Thank you.